Hello everyone, welcome to class 3 of CS1. I'm Pratap from Smears Education Solutions. I'll give you a brief introduction to continuous random variables in today's class. It's going to be very important for you if you want to develop the concept of statistics properly. When we talk about statistics, we come across random variables. When we talk about random variables, these are two types. One is discrete and the other one is continuous. When we talk about discrete random variables, you see this example. Here, the choices are finite, starting from 10 to 15. We talk about this one. Dr. Amit, how many patients you will see tomorrow? Suppose we know that he sees patients ranging between 10 to 15. These are the options for tomorrow, and the probabilities are here. From our past experience, we can specify probabilities. This is just like rolling a die. The probabilities are 1 by 6 in each case. Here, little bit up and down, like 0.17 in some cases and 0.16 in some cases. This is one of the example. There are several cases where we can use a discrete random variable. The number of students they will attend class tomorrow, the number of claims an insurance company will get next month or next year, the number of times you will watch this video. In all these cases, you will be able to find the probabilities in each case. These are point wise probabilities. If you sum up all probabilities, that will be one. It's straightforward. However, if you go to a continuous case, like the time it will take for Dr. Amit to complete a surgery tomorrow, the time, if you know that it normally takes between 10 to 15 minutes, here I've considered a uniform distribution. The time could be here, 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 and here. If you count the number of numbers between 10 to 15, they are infinite. We just can't explore infinite number of options. It's impossible. If you start counting from 10 today, you'll not be able to end in your lifetime till 15. So what we do is to get all, to complete all the points, we'll divide this line into intervals. So point by point, we have to complete here. Here, interval to interval. One interval, next interval. So how many points are here? How many options are here? We'll say 1, 2, 3, 4, 5, 6. How many options are here? Infinite, but we can do that way. So we'll specify. We'll count this way. This interval is one option, next option, continue this way. These are all the options we have. Now we'll try to sum up all the areas. For this option, this interval, the area is 0.09. For this option, the second interval, the area is 0.09. For the third option, the area of this this strip, this one is 0.07. That way, we'll sum up all the areas and we'll get the total area. Here we get the total length. Total sum is 1. Here total area is 1. So these are the areas of the strips, small ones. We can divide and we can sum up all these areas, we'll get 1. So remember, here point wise probability, here interval wise, we can explore everything. Here we have to add all the areas, we use summation sign. Here you need to integrate. This is also, the integration sign also comes from SUM. We don't write UM. So you have to sum anyway. You have to sum these areas or you have to add the numbers. That is the only difference. Another very, very important thing is how you write the probabilities. We write probabilities like this. But here there is nothing called probability x is equal to x. These are interval probabilities. So we have a name for this called PDF. We sum all intervals this way. We write summing fx dx. Here fx is called probability density function, PDF. Here PDF is the equation of this line. If you mark the total area should be 1. Here already the length is 5. So this should be 1 by 5. This this length should be 1 by 5 because total area is 1. So here f of x will be 1 by 5. Remember, f of x is the equation of the graph, equation of this line. It's a constant here I've taken. That's why I got 1 by 5. Otherwise, you can get in terms of x. Here we are able to write each probability starting from 1 up to 6. That means this one is 0.17, this one is 0.17. Individually we write, we don't need a formula. But we need a formula here. At any point, f of x is the height. So we have a formula here rather than an interval. Let's proceed further. Your ideas will get clear. We just can't add all these areas. This is one area, 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 this is one area. There is no formula to find this area. If you go to the previous slide, we added all areas because these are the small rectangles. We are able to find the areas. Even I've written all these areas. We know how to find area of a rectangle using geometry, but we can't find if I draw a graph arbitrarily. We found the areas because we just can't add all the probabilities this way. There are infinite number of points, so we can't add this way. So what we did is we divided into areas, and fortunately this was flat parallel to x-axis. So we got all rectangles, we added all areas instead of adding individual probabilities, which is impossible. Here we will not be able to find the area. That is why we need to use integration sign. We are integrating between 3 to 5 fx ds. This will give you this area because I've written 3 here, 5 here. If you want to find this area, you have to write this one. Similarly, for each shaded one with different colors, you have to write corresponding integration. So to find the areas, we'll use integration here. I mentioned everything. You can go through this. Now, when we talk about probability distribution, we have to divide into two parts: discrete distribution, continuous distribution, mostly. The properties I mentioned here, we have already discussed about the discrete distribution. If you have not watched my previous videos, you can go through those. Coming to the continuous distributions, we have the concept of probability density function. Here, probability mass function or probability function. In some cases, you can say probability distribution function as well. If you sum up all probabilities, you will get one. If you sum up all probabilities which are continuous in nature, you will get one. When we talk about minus infinity to infinity, we talk about left to right. Suppose this is the continuous one and you have probabilities at each point. This way. Then if you integrate from here to here, this will be 1. So this is left, this is right. It's not that always you get minus infinity to infinity. It will depend on the range of the random variable. So it should be positive always. That means all f of x, this is, remember, this is f of x and this is x. So it should always be positive. The graph is y f of x, and this is x. At each point you have f of x. It's positive, and if you sum up all these, it will be 1. Here also the same thing. However, we have options here and probabilities here. You need to add all this. We don't have anything in between. Going back to the example already I discussed before in my first video, how to represent the probability distribution of a discrete random variable. Here she has to think of a number between 1 to 4. So these are the choices 1, 2, 3, 4, and these are the probabilities 1 by 4 in each case. It's quite simple. However, if we give her a chance to think of any number between 1 to 4, not necessarily the whole numbers 1, 2, 3, and 4, she can think any number between 1 to 4. There are an infinite number of numbers between 1 to 4. In that case, although she will come up with a number, she will think of a number, but for the people who want to predict, it will be difficult to list all the numbers starting from 1 up to 4. We can't list all the probabilities. Again, this is continuous. So we have to take the help of f of x, the boundary. Here there is nothing called boundary because all the probabilities are specially there. So we don't need any such function to define the boundary. These are the probabilities, that is only boundary. So this will be replaced by f of x is now, which is probability density function. Now, in the same example, which was represented using the table, you can draw a graph this way. It's like a proper human, and this one is like a skeleton. You have only, we have gaps in between. So if you sum up, you get 1. If you find the probabilities, I mean areas here, interval probabilities, the areas will be 1. Now, what are the probabilities you can find here? Individual probabilities you can find, and interval probabilities also you can find here. I can write something like this: 1 to 4. 1 to 4 means 2 and 3. 1 by 4 plus 1 by 4. This will be 2 by 8. All kind of probabilities you will be able to find here. However, in case of continuous random variables, you can find point-wise probabilities. You see, I have not written probability x is equal to 1. If she thinks of a number, for me, it's almost impossible to predict. If you find the probability that she thought a number like 2.78, it will be 0. Because there are infinite number of numbers between 1 to 4, she might think any number. There are infinite number of choices. So we'll not try to predict this way. We'll definitely not be able to predict. Our probability will be 0. So we have interval probabilities. I've divided into 3 parts. I would like to predict using one of the intervals. If she thinks of a number, I will say either you thought a number between 1 to 2, or between 2 to 3, or between 3 to 4. I can give 3 choices. Here, this probability is 1 by 3, this probability is 1 by 3, this probability of 1 by 3. Here it's 1 by 4, the height. Here the height is 1 by 3. Because total probability is the area. This area is sum up all the probabilities. If you draw 1 by 1 line, if you sum up everything, that is equivalent to finding the total area. Total area should be equal to 1. If this is 1 to 4, 3, if this is 3, this should be 1 by 3. So I've written 1 by 3. Later you will be able to know how to use this one. Remember this graph, f of x will be 1 by 3 here. And this is part of a continuous distribution. We'll do in more details. For the time being, just remember it's 1 by 3. and the probabilities are equal for all the intervals. If you are asked to find probability x greater than 2, 2 are favorable, so you can say 2 by 6. If you are asked to find probability less than 3, again this side and this side, you can sum up these two, 1 by 3, 1 by 3, 2 by 3. Similarly, you can write all the answers here. It's not that every time you have to divide into 3 parts. It depends. We'll see more examples. Now, this is one example where f of x is a linear function. If you draw the graph, it will pass through origin because there is no y-intercept. This is our 0 and it will pass through origin. However, we don't know this angle. K is not known. The question is to find the value of k such that f of x represents a proper probability density function for a continuous random variable. When this will be a proper probability density function? First of all, this should be positive. F of x must be positive for all x. And if you integrate between 0 to 4, it should be equal to 1. That means if this is 0 and this is 4, if you sum up all the probabilities, that is the area, this area should be equal to 1. So you write the formula here. If you are typing using Word, it's very easy. This is directly available. You bring it and then you put 0 and 4, write dx, f of x, and you can copy paste many times, just change. It will not take more than 1 minute to write everything. This is 1. Use this, write the value of f of x, find k. So finally we got k 1 by 8. So our f of x will be x by 8, x upon 8 between 0 to 4. We are interested between 0 to 4. So we'll not bring minus infinity to infinity. Our left is 0, right is 4. So between 0 to 4, we are interested. This is a line. It's extending, but we are interested only this part. We are interested in this part. Total probability will be 1. You can check it. And the graph, this one is f of x is x by 8. Here you can find the area and you can check whether the area is 1 or not, because this is a triangle. You can always find the area. You find the intersection, you find the height, and base, half into base into find, you can do that. But we have integration already. So we integrated and we found this one k. So finally we got the density function. Now we have to find the probability that x will be between 2 to 3. You have to integrate 2 to 3. You see this part. Out of the whole part, 4 comes here. The total area is 1. The total probability is 1. We have to find this probability, this area. Then 0 to 1.5, that is less than 1.5, greater than 2.4, sorry, 2.1, then 2.1 to 4, this area. The total area is 1. We wanted to find part of the area. And part of the area, you'll be able to know once you integrate. It's a very simple linear function. We'll come across more functions, different kind of quadratic, logarithmic, all kind of functions in the subsequent classes. This much for today's class. If you are able to understand the concepts, if you enjoyed the video, please like and share this video and subscribe to our channel to keep up with our latest content. Thank you.